Hi everyone. So in this session, we are going to talk about constants or also known as literals in C programming language. Now, constant is something that does not changes over the time, right? During the execution, it must not change. So that is the intent for using constant. So constants can have different types and different representations, which we are going to talk about in this session. So in C programming language, constants are categorized into four or five categories. One is the string constant that is not mentioned here because string constant can be built using these characters. So we have integer constant, character constant, and collection of characters we call it string. Then next floating point numbers or floating constant and enumeration constant. So in this session, I'll be discussing about the integer constant, character constant, floating point constants, and the string constant. So enumeration is something that I will be discussing later on. Now, let's talk about integer constant. But before getting into this, I would like to stress on this point about this printf function. So printf function is one of the primary way to print out anything in the C in the console, right? And these are some of the format specifiers. For now, if you observe the format specifiers, you might not have the clarity if you have never used it before. So as we go through the constants, we'll be using this format specifier to print the constants which we are going to discuss. The first is integer constant. So in order to represent integer numbers, we use this concept of integer constants. So the C programming language allows integer constant to be written in decimal, that is base 10 number system, in octal or in hexadecimal, and in the modern C systems, we are we are even allowed to use the binary integer constants as well. We'll see that through examples. Now, in order to write decimal constants, so decimal digits can contain these numbers, these digits, it is allowed, right? That is 0 through 9. So 0 1 2 3 all the way up to 9, you can use any of these digits. Only the only constraint is that it must not begin with a 0. Any decimal constant must not begin with a 0. Yes, it is little different from our general mathematics, where if you write 0 1 2, it is same as 1 2, but it's not same in case of C programming language. So whenever we need to mention this decimal integer constant, it must start with non-zero digit. Why is that so? The second explanation, you can observe that octal constant, in order to represent octal constants, the digits allowed in octal number will be 0 through 7. And in order to represent this octal constant, the integer number must begin with 0. The integer number must begin with 0. Now, for hexadecimal, sir, in order to write hexadecimal digit, we can use the digits from 0 through 9 and the letters between A through F, where A represents 10, B represents 11, and so on all the way up to F for 15. And you can see these are some of the examples for hexadecimal constant. And as I said that in the 2024 standard, for the binary constant, we can even use we can start the number with 0b. So you can observe, in order to write binary integer literal, we can mention it through 0b. So you can observe here, I have written a piece of code here which shows different integer constants. Like first one is the decimal one. So when I print using this percentage d format specifier, so the percentage d format specifier says that any integer that you provide, it will always print in base 10 form. So you can observe this 2131, this is already in base 10 integer form. So when I print this, the output is 2131, as you can observe here, right? So I can take an example, maybe this is easy to understand. Even I can write a printf percentage d slash n, and I can write a number. So you can observe here that it starts with non-zero. So if I compile and execute, if I compile and execute this, I'll give the command here hello.c, and here output as hello, let's say. All right. Okay, I have actually the space. I have to provide the space between this c and hyphen. The compilation is successful, and now I'll execute this one. That is dot slash hello. So you can observe the integer literal is printed directly, right? Now, if I write the octal number, if I write this integer constant in octal form, let's say, if I'm writing, let's say 0 1 2, so this is octal representation. Now if I compile and execute this one, so you can observe this 0 1 2 octal constant is converted into decimal, right? If in case you want to print an octal itself, you have to use percentage o, right? So first of all, let me show you all the decimal part. So this is printing the octal, it is converting the octal into decimal, and then it is generating the output. And if I write hexadecimal, let's say 01A2, and let me take the binary as well, percentage d slash n for the new line, and here 0b110. So this is my number 6. This is binary. In binary it is 6. If I convert this 110 to decimal, that would be 6. Now let me execute this, compile and execute, compile and execute. So you can observe here that for the decimal number, it is printed as it is. The octal converted into decimal is 81, and the hexadecimal integer constant converted to decimal because of percentage d 418, and this binary converted into decimal, that is 6. So if you want to print as it is in their respective number system, so for octal we'll use percentage o, for hexadecimal we'll use percentage x, and for this we'll use percentage b. So if I compile and execute again, so it is going to print in the same number system. So I hope that is clear. So this was all about the integer constant. Now, along with the data types, we will study some more details about integers. But for a basic idea, this should be good for now, because one might argue that why you did not mention this L, okay, for long integer constant. So do not worry. In the discussion of data types, we will extensively talk about integers in more detail. Here, I just wanted to give you idea of integer constant. So you can observe in the first example, I have written everywhere percentage d, just to convert everything in decimal and print it out. In the next example, I have mentioned here percentage d for decimal, percentage o for octal, percentage x for hexadecimal, and percentage b for binary. Now, next we'll talk about character constant. So, character constant is also an integer internally. Why do I say that? Because for every character that I mention within this single quote, so first of all, we should be aware of the fact that characters are represented within single quote, and this character constant is internally an integer value end of the day, because the value of the character constant is the numeric value that is in the machine's character set. So for example, like most of the machine uses ASCII character set, where ASCII stands for American Standard Code for Information Interchange. So for every character, there is a ASCII value mapped to it. For example, if I talk about character 0, it has an ASCII value 48. So through the program, we'll observe this thing, right? So you can observe here, in order to print character, the format specifier that we need to use is percentage %C. So I've written character A within the single quote. So you can observe the output is A. Then the very same character written represented within single quote, and for this percentage %D, if you observe, when printed in decimal, so you can observe the ASCII value of this uppercase A is 65. Now when I go for 97, so 97 printed in decimal using the percentage %D format specifier, it prints 97. But if you observe this next line, that is at line number 7, this 97, when formatted using this format specifier percentage %C, then for 97, whatever is the corresponding lowercase character a, so that lowercase character a is printed over here, right? And the same thing I can show you for 0 as well. For example, if I am writing the character 0 within single quote, and the very same thing I'm writing this thing using percentage %C. So percentage %C will print the character as it is, and if I write percentage %D, it will print the ASCII value of the machine's character set, right? In the machine character set, if I have ASCII, so whatever is the ASCII value of this character 0, 48, that should be the output. So you can observe, when this character 0 is interpreted as an integer, in that case, the ASCII value, that is 48, is printed. And here the character is supposed to be printed directly because I have mentioned the format specifier as percentage %C. So I hope that gives a clear idea regarding characters. Now, so the character constant is a sequence of one or more characters that is represented within single quote. Now, the point is that if I write more than one character, it would give it it must give an error. So you can see it gives an error, it gives an warning over here, and this is some garbage value that is printed. Okay, we cannot say exactly garbage value. There should be some rule, some sort of logic will be there, that we'll be discussing. So why does it says that more than one character? Because for the escape sequences, for example, what about new line? So if I'm let's say interested in printing new line, so by appearance you can observe that there are more than one character. So sometimes combination of multiple characters can represent one character, like in this case of escape sequences, right? So if I compile this one, so you can observe it prints a new line, right? And for new line, the ASCII value is 10, right? Yes. So character constants participate in numeric operations that we'll discuss when we talk about operators and operations. We'll give more clarity regarding this. Now the ASCII table. So ASCII stands for American Standard Code for Information Interchange. So you can just go to this particular web link and you can just get the entire uh, ASCII table you can get to see. And for any character, if you want to observe their ASCII value, very simple. Just mention that character and use this format specifier percentage d, and you will get the corresponding ASCII value. For example, I want to check for b, let's say. So I'll compile and execute this one. So for lowercase b, it is 98. You can see, right? So this is also one way through the program you can get the ASCII values. Now, so escape sequences are also characters. This is something that we have already discussed, and we will be talking about this again and again, right? So these are the escape sequences that you can observe, right? So I encourage that you write programs and check by writing various escape sequences. Like for example, this slash a. So this represents the bell character. So I'll be writing slash a and slash a here. So this represents the bell character. So the ASCII value is 7. Similarly, you can mention percentage t, sorry, slash t for the tab, horizontal tab. So slash t for the horizontal tab. So I can just compile and execute this, and 9 is the ASCII value for this. Similarly, you can represent octal number in this form, that is slash in 3 digits, and then you can also write the ASCII values in hexadecimal representation as well, right? So one must have a good command over number system in order to handle this octal and hexadecimal number. If in case you are not having clarity regarding number system, I'll I'll sh- I'll record some videos regarding that. Do not worry. Now, so this I have taken from the 2024 documentation. It has same meaning. Only thing is that it has little bit of explanation. So I would encourage that you pause and read about it and write the programs using these particular sequence of characters. Now, let's talk about the floating constant. That is, in order to represent real numbers, we have floating point constants. So it will contain a decimal point like this. If you observe this number, that is 123.4. So this point is the decimal point, right? 123.4. So these are your floating point numbers or floating point constants. Or you can also write in a scientific notation, that is exponential form. That is 1e minus 2. So this means 1 times 10 power minus 2. If I write 1e plus 2, that means 1 times 10 power 2. So you can write in scientific notation as well as in open form notation like this. So if it has to be represented, so whenever any floating point constant is written, it has their type double unless we do not write the suffix. So what I mean by this, you can observe this example. So you can observe these are all floating point numbers, right? 6.31, 6.44, and 6.49. If you observe, I have written f in this case, in the first case. Then in the next one, I have not written any suffix letter, and in the last one, I have written l. So whenever we write lowercase f, that means it is of float data type, and float takes 4 bytes in memory. Anyways, in data types I'll discuss in more detail, but I'll just giving a brief idea regarding this. And when you do not write any suffix, that belongs to double data type. So that takes 8 byte in a 64-bit typical 64-bit architecture, right? And this represents long double, which occupies 16 bytes in 64-bit systems, right? So these are the values that are printed. And for printing floating point numbers, if it is a float type, use percentage f. If it is of double type, then we use percentage lf. And if it is of long double type, then observe this very carefully, that we write uppercase L and then lowercase f just to print long double floating point constants. Now, here we in C programming language, we have a compile time operator called size of. So what size of does, it takes this particular argument and just gives you the number of bytes that is allocated for a particular constant. For example, you can observe whatever the size of returns the number of bytes, I'm printing it using the format specifier percentage z and u. So you can observe, since this is a floating point type constant, that is 6.31 f, so this occupies 4 bytes, and you can see the corresponding output for this one is 4. So this represents 4 bytes. Then if you do not write any suffix, like for this floating point constant, that is 6.44, so this falls under the category of double data type, and hence 8 byte is the output. And if you observe this one, that is 6.49 l, the uppercase l, so this comes into the under the category of long double, and hence 16 byte as the output. So you can just experiment out this by yourself as well, right? Similar to this, let's say for this particular line, if I write percentage printf, let's say, within this within this if I write percentage zu slash n, I want to check size of my character, let's say size of this character a. So character occupies 1 byte in C programming language. So for this one, so since it is representing a number over here, because this internally is treated as an integer number, and that's why we are getting here 4 bytes, right? But if in case if I literally mention the char data type, if I literally mention the char data type, then it occupies 1 byte memory, right? So you can observe it prints 1 byte. So since this is a character constant, but internally it is treated as an integer, so integer occupies 4 bytes, and hence we are getting 4 bytes here, right? But when I mention this char data type, that is the keyword char that I'm using, so in that case the output is 1 byte, right? So I hope that is clear. Similarly, you can do the same thing for integer and so on, right? For example, if I write a numeric value, let's say 213, so in that case again I'll get 4 bytes. But if I use, let's say, l, if I append this letter l, let me just copy this line, and in the next line, for this integer, let me use the suffix l, so this means long integer. So in that case, if I compile and execute, you will get 8 bytes, right? So I hope you got little clarity, but these things in data types we'll discuss in more detail. Here my agenda is just to give you the idea regarding constants. Now, why the name is floating point type? Because this decimal point, the decimal point which you're observing, this point can float around actually, right? So that's why the name is actually floating point type. So for real numbers, we use the term floating point constants. Next, let us talk about the string constant. So string constant is always represented within double quotes, and we have been writing this string constant from day one through our hello world program, right? So the sequence of characters that we write within double quotes, that is my string actually, right? So, and if you observe here this is I am a string, and in this case if you observe, the string opens with the double quote and it closes with the double quote without any character. So such kind of string is called empty string. And please make sure this thing, that the quotes that we are using are not the part of the string. They are only for the they act only as a delimiter. For example, the starting double quote says that the string starts here, and the ending double quote says that the string ends here. So these just act as delimiter. And the string constants can be concatenated at compile time. Concat means to join the string. So you can observe here hello world is written. So you can observe clearly that this hello is written within double quote, and again after a space, again within quotes, we have written this word. So this is attached at compile time. So this particular line is equivalent to this one. So if you can observe here, let me just write. So you're writing hello space, and then after some space, I have closed this one. This is a single string, and I'm writing maybe abc, let's say. So writing this is same as this, that is printf hello space abc. Okay, so I'll be giving single space only here. So both of the statements are equivalent. So if I execute this one, compile and execute, so you will see that both are having same output. So let me give slash n over here, because printf does not supplies any new line automatically. So for better clarity, let me print the new line. So you can see both of the statements are same, right? Yes. So whenever we have to split strings across several lines, let's say I have a very let's say I have some statements to write, and they're very large strings, right? So I can hit enter, and I can separate them across new lines. Maybe this is def slash n, right? So I can write multiple lines like this is line number 4, something like that. Okay, so compile and execute, so this will be attached together. So you can observe these are all attached together, right? And this new line is coming not because I am supplying a new line, just because I am applying this slash in character, that's why. So please do not misunderstand. So you can observe here hello abc, and then this def and line is coming together because the new line character is something that I have not provided. So whenever you have to span your string over multiple lines, in that case we can use this particular structure, right? So that talks about string constant. And string constant is treated as array of characters. If you do not have any idea regarding arrays, do not worry about it. We'll talk about this thing, right? So you can observe this is one example. And this one, if you observe slash 0, so let's say while writing any string, let's say I'm writing here, maybe I'm writing here a b c d e f g h. So you can observe if I compile and execute this, it prints my string as it is, right? Now If I write slash zero, so slash zero represents the null character, and one must have a clear idea that this null character acts like a string terminator. If I execute this, observe the output. So you can see it prints only ABCD. That means printf, on encountering a null character, it will consider that the string is completed. So that's why the printf function is designed in such a way, or you can say the string in C is treated in this way, that if there is a null character, then after that it will consider the end of the string, right? So this null character represents the end of the string, and hence the printf has only read this ABCD, and rest of the part is ignored while the output is generated. So these are the various types of constants that we have in our C programming language. Okay, so to summarize, in constants, constant means something that cannot change over time. You cannot modify that, right? That is constant. So in C programming language, we have integer constant, character constant, floating point constant, and the collection of characters that constitute to string constant. So I hope you got the clarity. So I encourage everyone that you take a pause, and write some programs with printf. And finally, these are the format specifiers. So you can observe percentage %d for integer. Unsigned integer is something that I'll discuss. In that case, I'll talk about percentage %u, percentage %x whenever you want to print your integer in hexadecimal form, percentage %s for printing in string form, right? Then we have percentage %c to print in character, and then percentage %zu for having whenever you are using size of operator in C, right? So that's all about constants in C. As we proceed ahead, we'll study and learn more about it.